What is going on, YouTube? Welcome back. So for this week, I decided to come back to some technical content. My schedule has been a little bit tight, and I also missed doing technical content. I feel like I have a day job as a software engineer in Atlanta, and this does actually help add up for my day job. And I also am working on different goals in my career. So for this week, we're going to talk about API versioning, which is a way to manage different changes in an API in an orderly manner. So let's get into it. So to introduce this, good API designs try to maintain stability at the API specification level to minimize the need for multiple versions of the same API. Even well-constructed APIs need changes due to the evolution of requirements and/or different technology, and a slight alteration can either break the functionality for those who are using the API in their applications or lead to unwanted side effects. API versioning is the practice of developers improving their APIs while still leaving the prior iterations functional for clients. It gives users the freedom to upgrade to new versions at their own pace rather than forcing the updates onto them, which might break their existing application. And expecting every single user to update to the newer client version is not a reasonable expectation. How do we manage a new version on the server side when many clients might be using an older version? There may come a point where a developer aims to deprecate older versions of an API, but with versioning, consumers are given time and the option to update their applications to the version they desire. And however, not all changes warrant an entirely new version to be implemented. Let's take a look at what situations and alterations merit an upgrade. First, we'll evaluate the key principles of versioning and whether our APIs need it or not. Then we'll highlight how to implement and maintain it. So, versioning principles. Since API versioning is an important part of API design, here are some best practices that should be followed while versioning. So a new API version should not break any existing clients. So if several developers have adopted an API, introducing new versions could cause their applications to break. It's important to create new versions that don't break the applications that are still dependent on the old versions. And the frequency of API versions should be low. A release of another version is a huge investment and commitment on both the side of the provider and the developers who are using the API. The developers need to evaluate the new API and how it will affect their current applications. At the same time, the provider's side has to supply support across multiple versions so that there can be a smooth transition to the latest version. And we need backwards compatible changes. If changes in an API are compatible, then we can avoid making new versions altogether. Remember that backwards compatibility means newer code can read what an older software version has already written. So minor changes such as adding more query parameters do not really require changes to the client and will continue to work the same, so it doesn't really matter, right? To illustrate this, let's take a look at the pictures which illustrate an instance of a client making an API call to the server with mismatching versions. In the first slide, both the client and server are operating on the old version, so there shouldn't be an issue because the versions are compatible with each other, right? And in this scenario, the server has updated to a new version. However, the changes are backwards compatible. They shouldn't be an issue because there will be a contingency to handle calls from clients on an older version. And with both the client and server on the new versions, there shouldn't be any issues as long as the changes made in the new version don't break the client's application in any way. And here, the server most likely won't be able to handle the new API calls unless the server is forwards compatible, but this isn't always the case, right? So let's talk about when to version. Versioning is important, but what are some cases where versioning is not required? Let's start with an example of a mobile phone API where the developers are now tasked with delivering the phone's model and price and its information. This changes the phone's mobile info from a string to an object, with the model and its current price. If this is implemented without versioning, the API will repeatedly crash as it tries to parse the mobile info, right? So here in this example, we can see that our mobile application is calling our mobile phone API and we're getting a string, but then in our new example, we are actually getting an object which will cause our mobile phone to crash, right? And to resolve these breaking changes, a new version has to be rolled out, or else every consumer utilizing the API in their applications will encounter these problems. While incorporating these changes, the version of an API should be embedded in the request so that it can be routed to the correct entity, through which the users will receive the correct response. And the scenario above is just one situation where we implemented versioning. In the table below, we examine numerous scenarios and illustrate if versioning should occur in each situation. So in the scenario, a minor change that doesn't really alter the functionality, we don't need to change the version. And also backwards compatible changes, we don't need a new version for that. And altering the structure of a resource, we do need to version it, because changing a resource from a string to an object, such as the mobile phone API, we need to change the version there. And renaming entities, so if you're changing an entity from user ID to user credentials, then yes, you need a new version. And performance enhancing changes that affect functionality, like breaking the API into microservices, then yes, you need a new version for that, right? So in August 2020, Twitter released the Twitter API v2 for early access, which allowed faster functionality along with updated data formats. It wasn't until a year later, in June 2021, that Twitter retired its standard version 1.1 endpoint a considerable amount of time after it was displaced as a primary API version. So let's talk about API versioning semantics. Versioning semantics is a convention used to assign meaningful numbers to the released API, referred to as major, minor, and patch numbers. The semantic indicates backwards compatibility, incompatibility, and bug fixes of an API as listed below. So for the major, the significant change in an API that can cause incompatibility with older versions are referred to as major versionings of an API. For example, replacing the authentication method, the structural and behavioral changes in the existing features are considered major revisions of an API. And then you have the minor, which is adding new features in an API is a minor revision. For example, adding sign up with Google functionality in an API, keeping the existing options as it is, does not break the API functionality, and is also backwards compatible with the older version. And also the patch number. Fixing bugs or making small updates in the functionality of an API is referred to as patch versioning, and such fixes are also backwards compatible. For example, an API returning a user's data twice is a bug and can be fixed without altering an API's functionality. And in the illustration, 5 indicates the 5th major revision of an API, in which 1 new functionality was added as a minor update and 10 bugs were fixed in this new minor update. And note that some organizations may override the guidelines mentioned above. For this reason, the guidelines are subjective, right? So let's talk about different versioning approaches. There are several API versioning approaches that various companies across the world employ. So we'll take a look at the 4 most popular approaches below. So firstly is versioning with URLs. This is the most common method of versioning because it's simple and effective. The version information of the API is included within the URL in the form of an identifier such as v1. If a new version is introduced, a different identifier would have to be used such as v2. This method has the most maintenance cost compared to the rest of the procedures, right? And then we also have versioning with HTTP headers. In this approach, the HTTP header is used to specify the version of the API to be invoked. The preferred header for this approach is the HTTP accept header. This approach is favorable because it keeps the API version outside of the URL, which prevents it from being cluttered. And versioning using hostname. Another approach for versioning is to use a new hostname for each version. So let's assume that we have an API at the apiexample.com endpoint. We could implement a new version with a different host name, such as graph.example.com. This approach is only used when we have an extensive network of an API and we want to reroute the client requests onto a new server. So API version lifecycle management. Making changes to an API requires extensive planning and testing. The consumers of our API need to be notified of any changes we might want to introduce. Here are some of the ways this can be achieved. Announce the new version and versioning schedules. Send emails to registered users about the changes coming soon. Introduce warning alerts in older versions that are to be deprecated. Define a migration period and end date for support of older versions. Release a new API version as a beta release for a simple sample of developers to get feedback and find bugs. Launch the API while maintaining the old versions so that developers have time to migrate their code to the new version before the deprecation date. So in summary, the versioning of APIs is an important concept when it comes to design. We should design our APIs in a manner that doesn't require too many versions, or else it becomes a hassle in the development lifecycle. Now that we've gone over the basics of versioning, let's take a look at how to evolve our API designs in the next video. So let's do a quick quiz. Which option is true about API versionings? So A, all clients are forced to upgrade to the latest version when a new update is pushed, and B, a new version is required for every change to the API. C, the new version is never backwards compatible with the previous iteration. So the answer is D, none of the above. And which option is a versioning principle? So a new API version should not break any existing clients. And B, the frequency of major API versions should be low. And C, make backwards compatible changes. And the answer is D, all the above. And which option isn't a method that we can use to implement versioning? So versioning using a host name, versioning using a URL, versioning using query parameters, and versioning using CSS. So the answer to this is D, using versioning for CSS. That doesn't really make much sense. And consider a situation where we have a gaming API. Our gaming API has a health resource as an integer value. The developer then changes the health resource to include player hunger state, which is a string, along with its health points on the server side. Will this change require versioning? So we're basically changing our health from an integer to an object, or like a different data type, right? And so this will definitely require a version upgrade. So yes, it's true. So thanks so much for watching. I know some people were expecting some kind of self-improvement videos, which were fun, and they are really fun to make, and I want to make more of them and talk about other things like, technology and, the corporate game and things like that. But in the meantime, I'm making these technical content. I do enjoy learning this type of stuff. It does add a lot of value to my day job, and it's a lot easier to film. So if you like this video, like it, subscribe. If you have any questions or you want me to cover any other topics, leave a comment and I will try to get to that. And I will see y'all next week. So peace out.